Alright, so section 8.2 in 8.1 we talked about adding, or sorry, we talked about multiplying and dividing. This one we'll talk about adding and subtracting. And those are the two of the things we want to do is learn how to add, learn how to subtract rational expressions. The thing that we need to know how to do before that is to find the least common multiple. And that involves, when you're adding or subtracting fractions, you might remember, like if I'm doing 1/2 plus 3/4, I need these numbers on the bottom, which are called denominators, to be the same. And the least common denominator is another name for least common multiple. So I'll show you how to find that. First of all, with numbers, the way that you would find the least common multiple of numbers, 6 and 9, you can just list out the multiples. So the multiples of 6, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, and so on. The multiples of 9, 9 times 1 is 9, 9 times 2 is 18. So that means 18 is the least that they have in common. Okay, another way to do it if you don't want to list the multiples is you can make basically a factor tree. So if I make a tree for 6, that factors to 2 times 3, and 9 factors to 3 times 3. So what you want to do is take the most number of times that each factor occurs. So the most number of 2's that occur is 1, and the most number of 3's that occur is 2. So I need to include 2 of those. When you multiply 2 times 3 times 3, you do get 18. So that's how to find the least common multiple. How do you do it with polynomials? So here's an example right here. With polynomials, you would factor this. So this thing right here factors to x minus 2 times x minus 1. This thing right here factors to 2 times x squared minus 1. And then when you keep factoring, it's going to be x plus 1 times x minus 1, because that's a difference of squares. Okay, so then what's the least common multiple? We need to include everything, basically. So we need to include an x minus 2. We need to include an x minus 1. We've already included this x minus 1, so we don't need to include it again. We need to include that x plus 1, and we need to include this 2. So this whole thing right here, that is the least common multiple. It's basically what includes every piece of both of these denominators right here. Okay, so let's practice finding this. Let's find the least common multiple of these right here. Let's start with the numbers 6, 15, and 9. So we'll make our factor trees for these, and we're going to, again, include the most number of each factor. So this is 2 times 3, this is 5 times 3, this is 3 times 3. So we need to include the maximum number of 2's, and there's 1 2. We need to include the maximum number of 5's, there's 1 5. We need to include the maximum number of 3's, and this is the maximum number of 3's, there's 2 of them. Okay, then we need to include the most number of x's. So there's 1x, there's 2 x's, and there's 1 x. That means the maximum number of x's would be x squared. And the maximum number of y's, there's a y to the first and a y to the fourth. We're going to include the y to the fourth because that's the most. So 2 times 5 times 3 times 3, that would be 90. And then we still have that x squared and y to the fourth. So that is the least common multiple. Alright, how do you do it with polynomials? And the way you do it there is by factoring. So this, notice that that has a common factor of y squared. And then, whoops, before we factor the rest of it, let's see what's left when you pull out the y squared. So you pull out a y squared from this, you get y squared. Pull it out from this, you get 8y. Pull it out from this, you get 15. So we can keep factoring that. What number is multiplied to 15 and add to 8? That's 5 times 3 and 5 plus 3. So this is the factored version of that left side. This one right here can factor to y minus 8 times y plus 5, because 5 times negative 8 is negative 40, and 5 plus negative 8 is negative 3. So now our least common multiple has to include the most number of each thing. So I need to have a y squared in there. Okay, I need to have a y plus 5, and that also has a y plus 5, so I only need to include one of them, because that's the maximum number. And I need a y plus 3, so there's a y plus 3, and I need a y minus 8. So that is going to be my least common multiple right here. This includes each segment or each component of both of those polynomials. Alright, let's practice maybe one more of these. We'll do 1b. So this has a common factor of 4. So let's pull out the 4, and we get a squared minus 3a minus 4. And then we can keep factoring that to a minus 4 times a plus 1. Okay, this one right here has an a common factor, so we'll pull out that a. And then what does that factor to? What numbers multiply to 20 and add to negative 9? That would be negative 5 times negative 4. So our least common multiple has to include a 4, has to include an a minus 4, because that's in both of them, so we only need to include one. It needs to have an a plus 1, and it needs to have an a minus 5, and it also needs to have an a. So let's see that we have that, and you can see the a was just combined with the 4, so that's right there, and then everything else is included. Alright, so now how do you actually simplify, or how do you add these together? And we kind of already said that you need to have common denominators before you're allowed to add things together. So if we look at this one right here, they do not have common denominators. So the question is, how do we make them have common denominators? Let me just write this bigger so we can see it. So we have 2x cubed right here, and we have 8xy squared over here. So let's think about what's missing. First of all, 2 and 8, the common denominator would be 8. So this one is already 8. That means this one needs to get multiplied by 4 at least. And I have to do the same on the top. Okay, this one has an x cubed. This one is missing 2 x's in that case. It has an x, but it needs another x squared to get to x cubed. So even before we do this, let's just write our least common denominator. 2 and 8, the common denominator is 8. X cubed and x, it's going to be x cubed. And the y squared is just by itself. It needs to have a y squared. So that means this one over here also needs to have a y squared, because our common denominator is 8x cubed y squared. So now let's simplify this. So we're going to have this right here is going to be 8x cubed y squared. And so is this right here, the other side, 8x cubed y squared. Okay, this right here multiplies to be 12y cubed, and this right here multiplies to be 5x squared times z. So now at this point all we can do is just combine them into one fraction, because they have a common denominator, and that's what you do when you have common denominators. So this right here is the simplified version. That looks messy, and it is kind of messy, but that's really all we can do with that. Okay. What if you have denominators that are not single expressions or single terms? Those are called monomials. That last one we did. This is a polynomial. So how do you combine it in this case? And here's what you would do. So first thing we should do is see if we can factor this. So 6 times x minus 3 would be 6x minus 18. This has a 2 that could be factored out of it. So that was going to be 2x squared minus 7x plus 3, and then we could keep factoring that. What multiplies to 2x squared? 2x times x. It's a positive 3 but a negative 7, so that means they're both negative. And negative 3 times negative 1 equals positive 3. And if you had switched those, if you're not sure where that came from, you could always check that by foiling it out, and it would work. Alright, so let's figure out the least common denominator right now. So we need to have between 6 and 2, the least common denominator would be 6. Like, if, for example, if you were adding 1/2 plus 5 6, you would need to change this thing into 6 by multiplying it by 3. You always change the smaller one into the bigger one. So 6 is the number part of the least common denominator. Then we need to have an x minus 3, and that also has an x minus 3, so we'll include that. And then we need a 2x minus 1. So let's see how we can make that happen. So let's start with the left side first. So we need a 6 times an x minus 3 times a 2x minus 1. This has a 6 and it has an x minus 3. It's missing a 2x minus 1. So we're going to add that, multiply that I should say. So then the bottom is going to be 6 times x minus 3 times 2x minus 1. And the top, when we distribute the 5, it's going to be 5 times 2x is 10x, and 5 times negative 1 is minus 5. And then this is important, we have this minus right here, so I'm going to kind of keep that by itself for now. I'll explain what happens with that in just a sec. Okay, this one right here has almost everything. It has an x minus 3, it has a 2x minus 1, it needs to be 6, and right now it's 3. So I need to multiply that by 3 and multiply this by 3. So if I distribute the 3, I would get 3x minus 3, and the denominators are now the same, so we can combine these. Now I mentioned there's something with this minus right here. This minus is actually subtracting that whole thing, so you need to put that in parentheses to just be aware. You don't have to put in parentheses as long as you're aware that this is going to get distributed to everything. So our entire denominator here, this is now a common denominator, so we can just write it down at the bottom. And the top is going to be 10x minus 5 minus 3x and then this negative 3 becomes plus 3. So let's simplify that. So 10x minus 3x would be 7x. So that thing simplifies down to 7x. And then negative 5 plus 3 would be minus 2. So that thing simplifies to be minus 2, and that is the simplified answer. Okay. Let's try just 2 more here. So complex fractions, those are fractions over other fractions, and then with different lowest common denominators. So let's start with this side right here. We need a common denominator for 1 and x. So that 1 as a fraction, by the way, is 1 over 1. So what's the common denominator of those? Well, this one is missing an x. The one on the left is missing an x. So I could write, if I multiply the top and bottom by x, I could write that as x over x plus 1 over x. And hopefully that makes sense. What is x over x equal? It equals 1. Okay, so this can now combine to x plus 1 over x. That's the top right here. That's this piece right here. So let me just rewrite this here. Our top has now become x plus 1 over x. That's the equivalent of this. Okay, what does the bottom become? Well, 1 right here, 1 is the same as y over y. And then we still have that minus x over y. Why did I put it over y? Because this other one is over y and we need a common denominator. So we have x plus 1 over x, that whole thing, and now I can combine these into one fraction, y minus x over y. Dividing by a fraction is like multiplying by the reciprocal. So times the reciprocal of this would be times y over y minus x. And there's really no easy way to simplify that. The only thing we can do from here is just multiply x plus 1 times y, and we can do x times y minus x. And sometimes you can leave it like this, but in certain cases they actually just multiply this out, so we might as well do that. Y times that would be xy plus y, and x times that would be xy minus x squared. So either one of those is fine. Alright, what if they have, in this case, the same common denominators? And in this case, really what they mean is there's kind of 2 ways you could solve this. So this problem is the exact same as the other one. I'll just show you a different way to do this. So we could multiply everything by the least common denominator. I'll show you what that means in just a sec. So let's suppose we had a simpler example. Suppose we had something with just numbers like 1 plus 1/3 over 1 plus 1/2. What's the common denominator for 3 and 2? And the answer is 6. So if you wanted to get rid of all the fractions in one go, you could just multiply the top by 6 and the bottom by 6. The reason you can do this is 6 over 6 is equal to 1. And if you multiply something by 1, nothing happens. You're allowed to do that. So basically we just looked at these fractions. We said, what's the common denominator? This is going to make this easy because now when we distribute the 6, the top was 6 times 1 is 6, and 6 times 1/3 is 2. The bottom, 6 times 1 is 6, 6 times 1/2 is 3. Now that's easy to simplify. That's going to be 8 over 9. So what we're doing, this problem right here is the exact same as the problem we did on the previous page. The only difference is we'll try using a different method. Again, we already know that the correct answer is this one right here, xy plus y over xy minus x squared. You can use that method if it's easier for you. I just want to show you another one. So what's the common denominator for x and y? It would just be xy. Just like the common denominator for 2 and 3 was 2 times 3. The common denominator for x and y would be x times y, or xy. Okay, so let me just write this over here a little bit different. So I'm going to write xy, and then in front of this, what this is going to do is kind of get rid of all the fractions in one go. Again, why are we allowed to do this? Because we're multiplying by xy over itself, and anything over itself equals 1, so we don't change the value. Okay, let's distribute this now. So we'll distribute xy to both of these. So xy times 1 is just xy. And xy times this thing, the x here cancels with that, and we're just left with 1 times y, which is y. So xy plus y. And actually, let's remind ourselves on the previous page, that's already looking like the answer. The top was xy plus y. So this gets you the answer a little bit faster. And then down here, if we simplify xy times 1 is xy, and right here the y cancels, and we're left with x times x, which is minus x squared. That's the same answer we got on the other page. So that is section 8.2 on how to add and subtract rational expressions. Hopefully it helps you.